Hello friends, welcome back to the bench. Thank you very much for joining me. Our patient is our gaming laptop, which was, what was it? Well, it doesn't matter. We've seen it a few times now. So the quick recap of this one, this was the battery the charging port replacement gone wrong, some component missing, and it eventually led to an EC chip short. So we replaced an EC chip on this one, right? But I think it was here, if I remember correctly. No, on the other side. Yes, here. So this chip, this is PWM, very simple device, and it uses these two coils to create I think this one's 5 volts, this one's 3.3, or the other way around. That's how it works. It's a step-down converter or a buck converter, and the enable pins are controlled by the EC chip. So we have few components: the temperature shutdown, which is this one. And another temperature shutdown from the CPU controlled by this transistor. And the third thing that can disable it is an EC chip. So we figured that probably EC chip, because it was used, it doesn't seem to be shorted or anything, but it doesn't seem to work. So we expect that it just is not programmed to this computer. EC chip is basically a microcontroller, so the programming is relatively important. The chip itself, if it comes in empty, that's good. If it comes in empty, because then we can force BIOS to reprogram this one. But for that to happen, the BIOS voltage needs to be enabled. So in this case, the BIOS cannot program this chip because this chip is not letting the computer boot. I'm not sure, on some computers it will, if you put in the blank EC chip, it'll reprogram itself from the BIOS, but it all depends on how it's built. So we have another one, IT5570E, yes, 256, beautiful, and this one is supposed to be programmed to this motherboard. This is the motherboard. Revision C. So today what we're gonna do is we're gonna replace this chip, put the computer back together, and see if it works. Again, this is one of those cases that it took a long time to resolve, even a long time to get to this point, and I know about this board a lot more than I would like to know. That usually happens when there's a tricky fault to fix. You just kind of learn a lot more about how the board works and how it's built than you normally want to. Typically the faults that we like on computers is input transistor short, VRM on the GPU or CPU shorted, but the CPU being good, right? Maybe some crushed cap short, right? Those are easy to find, easy to fix. With this one, well, unfortunately, it needed a lot of short finding, or actually not short finding, fault finding, right? Now, what we're gonna use, I recently replaced my iron and my tip from a T210 to T245. Now let me show you the difference. So as you can see, we have relatively big difference. There's the scope, right? This one doesn't have this foam, so it looks a lot smaller. But with the foam, it looks a little bigger. As you can see, it's got melted many times from working on the motherboards, the CPU socket replacement. But the main difference is the thermal mass of the tip. So this is the tip that we usually use for these, and perhaps this tip will be too big. This is the other one, right? The tip itself is not that different, but look at the thermal mass of one and the other. It's a huge difference. So now with this 245, I can do a lot of stuff that I couldn't do with T210 without using a hot air to kind of, you know, help it a bit, right? I've been using it for a couple days now. I love it. It's the same iron, the same device that I use, A8 and A9 Pro. It's basically JBC knockoff, a lot cheaper and works pretty well. The power, as far as the power goes, this one is, I think, 300 watts. I think it says in the back, but I think it's around 300 watts of this one. So it's good for T245 or C245 tip. For if you have like 120 watt heater or 120 watt device, which is, you know, nothing more than a power supply with PID loop, and you get you know, the thermocouple reading from the tip, the sensor when you place it in, so it turns off, and obviously the power that is delivered to the heater. So there's like 2, 4, 6 pins over here, right? So we can freely replace these. You don't need to screw it in. It just plugs in and clicks in. There's a little clip, all right, that plugs in and holds it in place. So we'll see. I have one more, because I always get a few of everything in case it breaks. This one is the original that came with this soldering iron, and I have one more that I bought recently, or that I bought shortly after I bought the soldering iron. So I have a spare, and obviously plenty of tips and stuff. But with T245, I have only one tip. This is the only tip, and I don't think I will need more than this kind. I don't need a chisel tip or knife tip. I don't need any other tips because this one has so much thermal mass that you really don't really need any other kinds of tips. In addition, this one I use on anywhere from 370 to 380. I don't go below 370. This one works perfectly fine on 365. I'll probably even lower it to 345 because it's so big it doesn't need that much temperature. So it kind of depends what kind of tip you use and what kind of handle. So we'll see. There's not a lot of room around it, so I may need to. You see how close those caps are here and here, and last time we moved this diode. So perhaps this cap is super close. So we may need to actually change the tip to 210 because it looks like it's just gonna be too big. Let's put it close here. Yeah, I mean, but it's very easy to knock it off. Yeah, I would if I did it this way. But with this one, it has so much power, so much thermal mass that you can work with the tip alone. So I'll see about that. Maybe I can just use the very tip to solder it on. We'll see. It definitely makes a big difference in desoldering, because if you have a lot more power, it's much easier to desolder because temperature is your friend when you're desoldering. Alrighty, let's get to it. Alrighty, everything's back together. So the battery is charging, as you can see, and the light bulb also is lighting up a little. As you can see, it goes to like 16.15, right? And then drops for a second and back to 16.15 because the battery is fully discharged. So I think it's doing like some very gentle cycle to just kind of wake up the battery after like a month being discharged. No wonder. But what's happening is this is 5 volts, and as you can see, it's 0, 5, and 0, 5, and 0. So it's cycling, and the same with 3.3, right? 0 and 3.3 and 0. Actually, it's a bit high. Maybe that's the problem. Maybe one of the coils is shot. Now the low resistance I see on the memory, this is the memory, and it's stable 0. Because I was thinking if the CPU is faulty, it starts booting and CPU is not loading BIOS and it dies, and the EC chip is trying to restart. So it looks like EC chip works just fine. The BIOS voltage, this is 3.3 chip, as you can see, yeah, 3.3 and 0, or 0.3, 3.3 and 0, and so on. So EC chip seems to be working correctly, but it's either the CPU is not doing what it's supposed to do. Maybe that one coil over here on memory that has 22 ohms, it's a little low for memory, but I've seen as low as 0.2 ohms on memory, so it kind of depends on the CPU. But on this one, I would expect at least like 120, 130 ohms, not 20. The coil is relatively sizable, but I don't know. We have the battery on the BIOS and everything. It looks like power delivery issues are resolved, EC issues are resolved, but now it's just turning on. Something is wrong. It's detecting that something is wrong, or at least that's my assumption, and it turns off. But if this was a power issue, usually when that happens, you don't see the voltage for this long. You catch it on the oscilloscope, but it turned on. You see the pulse, and it drops immediately because there's a short or something's wrong. Typically, when it turns on for this long, and then just shuts down, this is boot loop. I would explain that with a boot loop, and EC doesn't really have anything to do with that, because it just hands over the booting procedure to the CPU, to the BIOS, and the BIOS takes over, right? And it starts booting and everything. But here we don't see fan spin. There's no fan spin, and thus there's no really reaction from the power button. So I'm not sure. What I'm gonna do is just let the battery charge. Maybe it's in some weird state, who knows. Technically it was the reset of the BIOS, because we uploaded the BIOS that will force the EC update. Maybe that's what it was doing. Maybe when I was testing it, it just corrupted itself during the procedure. I mean, it's possible. I don't know, is it possible? What do you think? This is like what, 2 kilobyte memory, right? So it just takes a few seconds. It's the same kind of concept as on the cars. When you clone the ECMs, it just takes, and it's programmed and downloaded and uploaded. It just takes literally a couple seconds because it's 2 kilobytes, right? The BIOS, on the other hand, that's like 16 megabytes, 32, even 128. I've seen big BIOS chips like that. So yeah, that takes a while. But this, so I would say rather unlikely, but and let's hope it isn't, because that's like a second EC chip that we put on this computer. I mean, it's better because with previous EC chip it wouldn't turn on at all and it wouldn't charge the battery. Now we're charging the battery and it's in the boot loop. Nothing really getting hot, nothing, power consumption is minimum. You can't really even see the light bulb. Maybe if I do this, can you see a little red light over there? Yeah, I don't, maybe. Maybe I can, but it is charging. So it's not charging with a lot of power though, right? I would expect this battery to start charging with like 20 watts or something like that. That would cause the light bulb to be relatively bright. But that is explained because BQ chip detected that the battery hasn't been charged in a long time and the voltage is like completely flat, right? So obviously you don't want to start charging such battery with full current because it will gladly accept that current, but you're risking uneven charging of the cells. So that's a whole other story. But this is normal. It's charging with low current until the battery is ready to accept higher current. Plus, it is probably also checking the health of the battery and stuff to make sure that none of the temperature as well, that none of the cells are faulty. They don't seem to be, and it looks like it's double cell battery, either double or yeah, it looks like double. Alrighty, if you guys have any ideas of what this could be, let me know. I'm gonna have to think about it a little longer, but first we're gonna charge it. But for this video, this is it. I would say my new handle works great, but since it's so big, I didn't want to take a chance and I put the Captain tape around the chip. And I'm glad I did, because I would definitely take some of those caps that were around it, or resistors. It would definitely suck them in. Alrighty, thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.